Welcome everyone to this course on regular expressions. We will be discussing the core concepts of regular expressions here, and hopefully will take you from 0 to 100 such that you can function on your own when it comes to writing your own regular expressions. Now, what are these regular expressions, or regexes for short? Regular expressions is a way in which we can define a pattern of text and search for that pattern in a large body of text. So practically we can search for any kind of textual data which has a pattern to it. For example, we can search for email addresses, people's phone numbers, their passport numbers, and any data that is embedded in HTML files or JSON files or XML files. All those can be extracted through pattern matching using regular expressions. So regular expressions are used to validate that the data is in the right format that we expect it to be in, and also to extract specific data from a huge load of data, and also to transform data from one format to another so that it could be easily consumed by whoever is expecting that transformed data. Now let me introduce you to meta-characters within regular expressions. Whatever you're seeing on the screen are meta-characters in regular expressions, and when they're used in regular expressions, they have a special meaning. Now, don't be overwhelmed by these meta-characters. We will be going one by one and explaining what are their special meanings when we apply them in regular expressions. Just remember that these meta-characters are dot, caret, $, star, plus, the question mark, backslash, vertical bar or pipe, curly brackets, square brackets, and round brackets. Now let us learn the usage of each of those meta-characters through demonstration. So we would be using the regex101.com site to do our demonstrations. And make sure that Python 2.7 is selected. So I am going to paste here a paragraph, and this is the fox and the grapes story. So it reads, one day a fox became very hungry as he went to search for some food. And it's about the grapes. Yeah, so the fox and the grape story. Now, after pasting this here, let me say that I want to search for fox. So I just type in fox here, and then you can see that the program has actually highlighted all the occurrences of fox. So this is how the search is being done. The regular expression is fox, and it is being searched for in the paragraph, and all the matches are being highlighted. Now instead of searching for fox, I want to search for all the characters A, B, C, D, and I can just punch in A there. It finds all the A's. B, it finds all the B's. C finds all the C's, and D, it highlights all the D's. So how do I now write a regular expression such that I want to highlight all the A, B, C, and D's? So the way we do it is by using the square brackets, and then we put in A, B, C, D, close brackets. Now it finds me all the characters A, B, C, and D. To really drive home this concept, so let me type another statement with just A, B, C, D here. So you can see that all the characters in ABCD is matched as well. Now when we use a square bracket, what we are really telling the regular expression is that we only want to find one character, but the character could be A, B, C, or D. So this is what it is doing. It is highlighting if a character is A, B, C, C here, and then D. And in this final case here, because we have A, B, C, D, it's highlighting each of the characters here. Now what happens if we remove the square brackets from ABCD? Let's try that. So removing the square brackets. Now when we remove the square brackets, the regular expression is going to search for 4 characters instead of 1 character, and it's going to search for a pattern ABCD, and we can now see that all the A, B, C, D individual characters are not highlighted. Instead, only if only an occurrence of ABCD together is highlighted. Let's say now that we want to find all the characters from A to Z. So how do we do that? So we start with the square brackets, and then we add one character one by one. So A, B, C, D, E, F. We can keep on going like this. Now, is there a better way to just denote a range of characters? Yes, there is a better way, and that is by using the hyphen. So A hyphen Z will match all the smaller case letters from A to Z. we can see that it only matches the smaller case letters, and the capital case letters like A here and F here, O here, these capital case letters are not matched. How do we include the capital case letters as well? So just include the range using capital A hyphen capital Z, then it matches all the letters. Now let's say that we also want to match these spaces. How do we do that? So add the space into the square bracket, then it matches the spaces. And now let's say we want to also match the comma. Just add the comma into the square brackets. It now matches the comma. Now let's say that our purpose is not to match all these characters in this range, but is to match any character that is not in this range. So how do we flip it around? How do we take the complement of this? The way we do it is by adding a caret at the front of the square brackets. So now just after adding the caret, we see that it matches now any character that is not in this range within the square bracket. So that is the apostrophe, the full stop, the double quotes, etc. Now taking a smaller example, let's say that I want to match every character that is not an A. So first I can just put an expression for a regular expression for matching all the A's, and then I just add the caret in front of it and it matches everything which is not an A. So this concludes this particular session, and in this session we have seen how to use the square brackets and the caret within the square brackets. Welcome to this session, and we will start with a clean slate in this session, and I will paste a paragraph which is the word abacus repeated multiple times. And let us now search for the word abacus. So you can see that it's matching each and every occurrence of abacus. Now what if I only want to match the abacus that is in the start of every line? How do I do that? I don't want to match all of these abacus that happens in the middle or the end. So the way that we do that is by adding a caret in front of abacus. So you can see that it now only matches the start of the sentence. Now please remember that using the caret in front of a pattern just indicates that we want to search at the beginning of every sentence. Now let me just contrast this with the other way caret is used. So when we use it in front of a pattern, it just looks in the beginning of the sentence, but when caret is used within square brackets, it has a totally different meaning. It means that we want to look for all the letters apart from the ones mentioned. So it's a complement function. So you see how it works differently. So removing the square brackets, we are just indicating that we want to look for abba, but the one that occurs in the beginning of the sentence. Okay, now let's say that I want to look for the word abacus, which is at the end of every line, end of the line, instead of at the beginning. So now we can see that I just mentioned the pattern abacus and it finds me every abacus in the paragraph. So let's say I just want to find the abacus at the end of the line. So I use the $sign for that. So once we use the $sign, it's only looking at the end of the line and then finding an abacus that occurs at the end of the line. Now let's say that I only want to match the abacus where the A occurs after the start of the line and the S occurs before the end of the line. So how do we do this? We have to both use a caret and the $sign. So let's use a caret first. So it finds me all the abacus that starts just after the start of the line, and using the $sign, I find the abacus with the S just before the end of the line. So it's only one match here in this particular case. Now let us say that we want to match abacus which occurs at the start of the line. So we have caret followed by abacus. Now let's say we want to match two abacus that occurs at the start of the line. So I just want to add another abacus here. So it matches for two abacus which occurs at the start of the line. See that the first one is not matched because it's only one abacus. And let's say I want to match three abacus which occurs at the start of the line. So it gives me three abacuses with the start of the line, whereas you can see that the first row and the second row is not matched because it's one and two abacus respectively. Now, is there a better way to look for repeated words? Yes, there is a better way, and that is by just mentioning abacus, and let's put the abacus in the round brackets, and let's use the curly brackets and mention the word number 3. So using the curly brackets with a number there mentioned there, we can actually look for repeated words. So the regular expression now searches for the word in the parenthesis or the round brackets 3 times. So it matches all these lines, and we can see that the row 1 and row 2 are still not matched. Now, what if I want to match for 4 abacuses that occurs at the start of the line? No problem, just change the number here. So 4 abacus is matched, 5 abacus is matched, 6 abacus is matched, and you get the idea. Now let's say that I want to make a regular expression that looks for 2 abacuses, 3 abacuses, 4 abacuses, 5 abacuses, or 6 abacuses. I mean, it could be any of those. So how do I provide a range of repeated patterns to look for? So I can use the curly brackets for that, and I mentioned the number 2, 6. 2 without the space. So now it looks for occurrences of abacus 2 times, 3 times, 4 times, 5 times, or 6 times. So you can see that the first row and all the other the rows with more than 6 times, those are not matched only until the 6 abacuses is matched. Now, what if I only want to look for repeated abacuses, which is at least 2 times, and there is no upper limit? So we can do that just by removing the upper limit and keeping the comma in place. So you can see that all the abacuses, repeated abacuses, are matched except for row number 1, which is only 1 abacus. Welcome everyone to this new session. In this session, we will be looking at the pipe meta character and its usage. So let me paste this paragraph here. So this is the baby, the toddler rhyme. I like to eat apples and bananas, ate apples and bananas, etc. So we will be using this paragraph. Now let's say I want to search for eat. How do I do that? Just use eat as the regular expression and it finds me all the eat. Let's say I want to find the 8. So it's ATE. I use that and it finds me all the 8s. Now, how do we look for either eat or 8? So let's see how that is done. So I type in eat first. It finds me all the eat. I put the eat in the curly in the round brackets, and I use the pipe character, and I also mention the ATE8. Now, so the pipe character is choosing between either the pattern on the left or the right. So yeah, it finds me all the eat and the 8. And I can further just simply expand this logic to find all the ites, the oats, and the oots. So let me just add those here. ITE first, it finds me all the ites, and the OTE, oat, and finally the oot. So it finds me all of those different patterns. The pipe character is just it's saying either or, either or, either or. Yeah, and it's finding us all of the eat, ate, oat, and oot. Now let us take another example. Let's say we want to match all the T's in this paragraph. So just type T and it matches all the T's. And let's say if we want to match the T followed by a space, I just added space to the regular expression and it matches me all the T's followed by the space. Now let's say instead of the space, I want to match the T followed by the comma. So I just add it into the regular expression and it finds me the T followed by the comma. Now the question is, how do we find all the T that is either followed by a space or a comma? So the way to do that is by using the pipe character, and we will use the round brackets first, mention the space first, and the pipe followed by the comma, and close the round brackets, and it finds us all the T's that is either followed by a comma or followed by a space. Next, we will be taking this example and looking at the usage of the plus sign and the star sign. Let me start by searching for LD, and it matches all the LD in the different lines. Now what if I want to match the cold with the 1 O, the cooled with the 2 O's, and the cooled with the 3 O's? One way is to use the pipe character as we saw earlier. So I can start with C followed by a round brackets, and I will put 1 O, pipe, 2 O, pipe, 3 O's, and it matches me all the all these 3 rows with 1 O, 2 O's, and 3 O's respectively. And yet another approach would be to use the curly brackets. So let's try that. So I could mention O followed by the curly brackets, and I will say that I want to start a match at 1 O up to 3 O's, and then close the curly brackets, and it finds me 1 O, 2 O, 3 O within the code. And yet another approach is to use the plus sign. So let's type plus after the O. And what the plus sign does is that it indicates to match the previous character at least one time or more than one time. And hence it matches line number 3, 4, and 5 where O occurs at 1 time, 2 times, and 3 times. And this approach not just works for characters, it also works for groups. So let me type in these po, po, mo, mo, po, 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 mo, and po here. And let me find out all the pos. So it finds me all the pos. And let me say that I want to match all the pos that is followed by a mo. And so here we have highlighted 2 matches. So let me add more here as well, so it all is matched as well. Now let's say I want to match all the repetitions of this po. So po mo should be matched, po mo should be matched, po mo should be matched. So how do we do that? We can either use the curly brackets and mention 1 to infinity, so it matches everything. Or we could instead use the plus character. So let me type in plus, and it matches all the same matches. So po mo, po mo, and po mo, they are all matched. So to drive home this point, so what the plus sign it matches is that it looks at the previous character or group, and then it matches that character or group one time or multiple times. Let's move on to a fresh example. And in this example, we want to match CLD, COLD, COOLD, or COOOLD. So that means whether O occurs 0 times or 1 time or 2 time or 3 time, we want to match those. So how this is done is we start with the C, and then we mention O, and then we can use the curly brackets and say that we want to match it 0 times or more times, close the curly brackets, and followed by LD. So it matches everything. Another way is to, instead of using the curly brackets, I can just use the character star. So it does the same matching. So what star does is that it tells that the previous character or group should be matched 0 times or multiple times. Now let's use star to find a group as well. So and let's find the most first, and then I'll mention po, but I want po to be a group, and I want po to be matched 0 or multiple times. So I use a star, and we can see here that po occurs 2 times here, 3 times here, 1 time here, and in mo, po occurs 0 times, but it is still matched. Now let me introduce you to another meta character, which is the dot. So for that, let me use this as a paragraph. So we have cold, bold, mold, rolled, etc. And let us try searching for old first. So it matches all the old. Now what if we want to match the character that is before old as well, which is, it could be C, it could be B, it could be M, it could be R. Now one approach is that we can use the square brackets, and we can just mention all the range of letters, so it matches everything. Another approach is to use the pipe within the round brackets. So C, pipe B, pipe M, pipe R, close the round brackets, and it matches all the letters. And yet another approach is to use the dot. What the dot does is that it matches any character, whether it's a letter, a number, a comma, semicolon, etc. So in our case, it matches any character that occurs before the old. So it matches a C, B, M, R in cold, bold, mold, and rolled. Now one thing to note is that the dot only matches one character and not more than that. Now let us try using the dot as the regular expression, and we can see that the dot matches every single character, one character at a time only. But what if we want to match the entire line? So the way to do that is use dot followed by a star. So and now it matches every line. So we earlier saw that what star means is that the previous character is repeated 0 times to infinity, right? So dot star is a way in which we use to match any generic string, any generic line. Now let's say that we don't want the regular expression to match the entire line, and let's say in our case we only want it to match until the LD. So we input LD after the dot star. So let's do that and see. We can see that the matching is stopping at LD. Now the star in regular expression is considered greedy, meaning it will try to match as many characters as possible. Now let us say that we don't want the regular expression to start matching from the beginning of the line, but instead from the space. So let's insert the space into the regular expression and we can see that the matching is updated accordingly. We again notice that the star matches as many characters as possible. The regular expression could have only matched space bold or space cold, but instead it is matching space bold, space cold together, so which indicates that the star is actually greedy. Now we will be looking at the usage of the meta character question mark. For that we will be using this paragraph here. There is orange, oranges and mango mentioned. Let's say we want to match orange, so I type orange and it matches the orange. But what if I wanted to match both orange and oranges? How do we do that? One approach is to mention S first, followed by the curly brackets, and I mention that we want to match S 0 to 1 time, and it matches both orange and oranges. Another approach is to use the question mark sign. So we use question mark here. What the question mark indicates is that the previous character or group is either existing 0 times or 1 time. So it matches orange and oranges. Now let us look at the usage of the meta character backslash. Now let's say that I have this paragraph here and let's say we want to match $100. So I type in $100, but it doesn't match. It doesn't match because $sign itself is another meta character. It indicates the end of a line. So if I remove the $sign, it matches the 100. And I can add the $sign to the end here and it still matches 100 because $sign typically indicates the end of the line. So how do we really match $100? So the way to do that is by using the meta character backslash and use the $sign after the backslash. Now it matches $100. The backslash is used as an escape character and it indicates that the character that comes after the backslash needs to be literally searched for and should not be interpreted as another meta character. And backslash can be used to escape other meta characters as well. Let me add a meta character here around me. And let's say that further we want to match the square brackets me. Let's first type me and let's match the opening square bracket first, followed by the closing square bracket. So this is how we escape other meta characters such as square brackets. Welcome to this challenge. As per the challenge description, what we want to match is Madoop with the capital M, Madoop with the small m, and Sadoop with the S. We don't want to match Kadoop or Hadoop. So let us see how this would be done. First of all, let us write the regular expression to match Adoop. So ADOOP. And additionally, now we want to insert a first character match, and the first character should only be capital M, small m, and S. It should not include K or H. So now let us use the square bracket meta characters in order to select multiple characters that we want to selectively include. So let me mention the square brackets and include capital M, small m, and S. So we can include K and H if we want to match those as well, but because the challenge does not include those, we will just finish with capital M, small m, and S. Welcome to this challenge. Now in this challenge we see that it matches every Hadoop word except for the one that starts with H. So it would be easier for us to first write a regular expression to match Hadoop and then take the complement of that. So let's match Hadoop first. So HADOOP, and we have matched Hadoop. Now how do we take the complement of the first character for the match? For that, we have to include the first character within square bracket meta characters. So let's do this first. And then we mention a caret as the first character within the square brackets, which indicates that we are looking for the complement of all the characters that is within the square bracket. So what is included in the square bracket is h. So the complement of h would be all other characters which are not h, and so it matches everything except for Hadoop now. Welcome to this new challenge. In this challenge, it is matching Hadoop, Hadoop and Badoop. And another thing we notice is that the Hadoop is repeated here, but this is not matched, and the Badoop is repeated here, but this Badoop is not matched, and the Hadoop is also repeated here, but it is not matched. So there should be something to do with the starting of the sentence, which should be included in the regular expression. So let us solve this challenge by matching the Hadoops first. And we can match the first character in front of the Hadoop by just using the dot meta character. So you can see that it's all the Hadoops with V, U, T, etc. are matched now. But we only want to match those words that are in the start of the sentence, and for that we use the caret meta character. So we can see that these three matches as per the challenge needs requirements are met. Welcome to this new challenge. In this challenge, only the Hadoop starting with N, 1 and O are matched, and that too they are occurring at the end of the sentences. So as with previous challenge, we find all the Hadoops first, and we use the dot character to match the full word, and finally we use the dollar meta character to indicate that we only want to match the Hadoops that occurs in the end of the sentence. So challenge solved. Welcome to this challenge. In this challenge, we are only matching the Hadoops that start either with a K or J. So this Kadoop, Jadoop, Kadoop, Jadoop, and Jadoop, Kadoop. These are matched. So let us match the Hadoops first. So I type Hadoop and it matches all the Hadoops. And finally, for the first character, I can use a square bracket meta character and include the selection that I want to include. So J and K. So this solves the challenge, and this is one way to solve the challenge. Now the second way is to use the pipe meta character. So let me clear this and use the round brackets first, and we can input the characters K and J, which are separated by a pipe, and it matches the required matches that we want to match. Welcome to this new challenge. In this challenge, as in the previous challenge, the Kadoop and the Jadoop are matched. But then this Kadoop and this Jadoop are not matched. So what's going on? How do we formulate this regex? So let's see. First, let us start with matching all the Hadoops. So let me type Hadoop here, and all the Hadoops are matched. And let's only match the Jadoop and the Kadoop now. So let me use the meta character square brackets, and we will mention J and K. So all the Kadoop and Jadoop in these three lines are matched. However, we don't need to match this Kadoop and Jadoop here on this last line. So how do we do that? If we analyze the first two match sequence, right, the Kadoop and Jadoop, they are occurring next to each other, whereas for the third match, the Kadoop and Jadoop are not occurring next to each other. There is Madoop in between. So we can use that for our advantage. So we can simply get rid of this match by using this regex twice. So let me do that. I'll just copy this regex and add it after a space. So now it only matches the first two occurrences, and the final match which used to match previously is not matched anymore. Now if we analyze the regex more closely, we can see that it's a repeating sequence of regular expressions. So instead of just repeating it like this, we can use the curly brackets to indicate repetition. So let's see how that is done. So first we will remove this second component of regex. So let's do that first. And the first component of the regex, we will put it within rounded brackets so that we can apply a curly brackets later on it. So now I will use the curly brackets, and I will mention how many times I want this component of regex to be repeated. So I want it repeated twice. So yeah, there you go. So it now matches the Jadoop and Kadoop occurrences which occurs together, whereas it doesn't match the Jadoop and Kadoop which occurs with another word in between, which is Madoop. And we can even have a slightly modified version of this regex. Instead of the square brackets with the JK, we can use a rounded brackets with the JK separated by a pipe, as in the previous example. So let's see that as well. So remove this and then add the rounded brackets with the JK separated by a pipe, and it has the same matching effect. Welcome to this new challenge. In this challenge, we have to match the bird that occurs at the start of the sentence and also the birds that occurs at the end of the sentence. So how do we do this? So let's first try to find the bird that occurs at the start of the sentence. So we will use a caret to signify the start of the sentence followed by bird. And so this is how we find all the birds that occurs at the start of the sentence. And to find birds that occurs at the end of the sentence, we will use bird, and there is a space following it, so space, and followed by the $, which indicates the end of the sentence. So this is how we find birds at the end of the sentence. So how do we combine these two logic together such that we find the bird that occurs at the start of the sentence and also the ones those occur at the end of the sentence? We will use those two logics joined together by the pipe. So let's see how that is done. So let's first put this regular expression component within rounded brackets, and let us also use another rounded brackets with the caret sign followed by the bird to match the birds that occurs at the beginning sentence, and then let's use a pipe. So this is how we match both the birds occurring at the beginning of the sentence and the birds occurring at the end of the sentence. Welcome to this new challenge. In this challenge, we are tasked to find birds that occur together either 2 times, 3 times, or 4 times, but then they should start at the beginning of the sentence. So this is a challenge. So let us start by finding birds that start at the beginning of the sentence. So for that, we will use caret followed by bird. And if we want the regex component bird to be repeatedly searched for, we have to put it in a rounded bracket. So let's add the space as well so that the space is matched, and put the bird with the space in the rounded brackets and use the curly brackets to show repetition. So, and within the curly brackets, we will mention the numbers 2, 4 so that it matches occurrence of bird 2 times, 3 times, or 4 times, which are beginning at the starting of the sentence. So challenge solved. Welcome to this new challenge. In this challenge, we are tasked to match the birds that occurs 2 times, 3 times, or 4 times, but then the starting occurs at the start of the sentence and the ending of the sequence occurs at the end of the sentence. Those which does not end in the end of their sentence are not matched. So let us start with the caret, which indicates the start of the sentence, and let's put bird space. And now we want to repeatedly search for bird space as a regex component. So we put it within round brackets, and we use the curly brackets to mention the repetition we need. So we need it repeated 2 times until 4 times. And we only want to match those ones that end in the end of the sentence and not the ones that do not end in the end of the sentence. So for that, we use the $, metacharacter. So challenge solved. Welcome to this challenge. In this challenge, we are given the word country enclosed in curly brackets, and one with a single quote, another with a double quote, and country enclosed within square brackets. And our task is to find every country that is enclosed within the curly brackets. So let us first write the regular expression to match every line in the given paragraph. So that's dot star. So it matches every line in the given paragraph. The next step is to match the opening curly bracket, and we know that the curly brackets is a meta character, so they need to be properly escaped. So I'll use the backslash first followed by the opening curly bracket. So it already matches the required 3 lines, but just for completeness sake, we will also match the closing curly brackets. So the requirement of the challenge is already met. Welcome to this new challenge. In this particular challenge, instead of matching just all the country enclosed within the curly brackets, we are tasked to match the one enclosed in curly brackets plus the single quotes. So let us start by matching every line. So every line could be matched with dot star. And let us also match the countries that are enclosed within the curly brackets. So let's use the escape character followed by the opening curly brackets, and finally also escape character followed by the closing curly brackets. So 3 lines are matched now. Now, in order to look for the single quote, we can use the single quotes within the regular expression. And one thing to note is that even though single quotes and double quotes are not meta characters, it is a best practice to escape them as well. This is because single quotes and double quotes could be used to start or stop textual information in many languages like Python and Java and all that. So we don't want to accidentally end the textual data in the original language by using our own single quotes or double quotes. So it's always a best practice to escape them. So in order to include the single quotes in the regular expression, I will escape using the backslash followed by single quotes. And I will also, before the ending curly brackets, I will do a backslash escape and followed by a single quotes. So now it finds the correct line that we want to find. Welcome to this new challenge. In this challenge, we are tasked to match both the countries which have been enclosed in a single quote and a double quote. So let's see how this would be done. Firstly, we would use the dot star to match every line. And we would look for the starting single quotes by doing an escape backslash, starting single quote, and also do the same thing for the ending as well, and a backslash escape followed by single quotes. So it now matches one line, which is the country enclosed in single quotes. Now, in order to also match the double quotes, we would put the single quotes in a rounded bracket and use a pipe meta character. So let's do that. So let's put the opening single quotes in a round bracket and use a pipe operator or a meta character and followed by backslash escape double quotes. And let's do the same thing for the ending. So we put the single quotes in a round bracket, use the pipe operator, use escape backslash followed by the double quotes. So it now matches both the countries enclosed in single quotes and double quotes. In order to also match the starting curly brackets and the ending curly bracket, we can simply add a dot which matches any character. So add dot to the start and the end. Now it matches completely these two lines. So the challenge is solved. Welcome to this new challenge. In this challenge, we are tasked to match both the countries that are enclosed in the single quotes followed by the curly brackets and the country that is enclosed in the square brackets. As in the previous example, let's first write a regular expression to match the country which is enclosed in the single quote and double quote followed by the curly brackets first, and then we will deal with how to match the country enclosed in the square brackets. So let's write a regular expression to match every line, that is dot star, and then first look for the opening curly bracket. So backslash curly bracket because it's a meta character, and then followed by also backslash single quotes, looking for the single quotes. Now because there is a it can either be a single quote or a double quote, so let's put the single quote in a round bracket and use a pipe operator and also mention the escaped double quotes. Yeah, so now two lines are matched, right? And we don't necessarily have to match the ending part because dot star matches until the end. So let's just cut and paste the regular expression maybe below here, and let us now focus on how to match the country which is enclosed in the square brackets. So again, starting with matching every line, which is dot star, and then looking for the opening square bracket. So that is using an escape backslash square bracket opening. So it's now matching the one single line that we wanted match. So also let's cut this and paste it below. So here I have pasted it there. Now because we want to match the country which is either enclosed in the single quotes or the double quotes or the square brackets, we have to make use of these two regular expressions, but you pipe them together. So let's see how that is done. Before we pipe them together, we put each of these regular expression components in a rounded bracket so that they can be counted as one group, and then we mention the pipe between them. So let me cut this and paste it here. So now it becomes one single regular expression. Once we paste it, it's matching the three lines that we wanted match, and the challenge is solved. Welcome to this session. Here we will be discussing the real world example of how to match real world data. So in this example, we will be looking at a bunch of data which includes email addresses, IP addresses, and Bitcoin addresses. But then we will be writing a regular expression to match only the email addresses. And if we examine the email address data in this given sample data, there is an @ symbol which separates the first part of the email from the last part. And if we examine the first part of the email, it is usually a combination of smaller case letters with numbers. So let us write a regular expression to match the first part of the email. So we will start with mentioning the square brackets where we can define a range of characters to look for. So we will mention the range A to Z. So it matches all smaller characters A to Z. And we will also include the numbers 0 to 9. So it matches all the numbers as well. And we will use the plus meta character, which indicates that the previous character, which is defined within this square brackets, should occur one time or more than one time. And next we will mention the @ symbol so that the first part of the email until the @ symbol is matched. And now if we analyze the second part of the email, now it has smaller case letters and also sometimes digits followed by a dot and another part which is the ending part, but certain examples have two dots. So as in this case, hatina.ne.jp. So we would have to construct this regular expression logic now. So again we would use the square brackets to match a character class, and we will mention A to Z as a range, also 0 to 9 to match the number range, and we will use the plus sign so that it matches the previous character which is within the square brackets at least one time or more. Next we would have to look for the dot, literal dot. So because dot is a meta character, we would have to escape it before we put in the dot. If we do not escape this dot, then it will just look for any character and match any character rather than just looking for the literal dot. Next, let's write the regular expression component to match the final ending part here. So we will use the square brackets again, mention the character range A to Z and 0 to 9, and we will use the plus sign so that it matches one or more times the character range within the square brackets. Now if we have a quick scroll through of these email addresses, we can see that it matches almost all of the email addresses except for the ones where there is double dot. So as in this example here, .ne, until .ne is matched, but then there is a .jp component as well which is not matched. And again if we scroll down, we can see that there is another email address here which is this one here, Merriam-Webster.com. It is not matched because we are not searching for hyphen. So we would have to adjust our regular expression logic to include and look for the hyphen as well. So we can address this quickly just by adding in hyphen to the component, regular expression component that is just before the literal dot. So let's add in the hyphen component there. Now you can see that it's being matched as well. And let us also address the issue of the double dot. So the double dot is this one here, .jp is not matched. So we can see that the .ne.jp, so this can simply be addressed by repeating this group of regular expression component one time or two times. So in order to mention that this component here, let's put it within the round bracket, and it should occur at least one time or two times. Let's use the curly brackets, and then let's say that it should occur at least one time and a maximum of two times. So once we mention that, we can see that the .jp is also now matched. So this challenge is solved, and now we have a regular expression to match most common email addresses. In this session, we will be writing a regular expression to match all the IP addresses that is present in this raw data. If we analyze the pattern of the IP address, we can see that there are 3 literal dots and there are 4 number sections which are actually separated by the 3 literal dots. And these numbers can go from 0 to 255. There are very complex ways of writing regex for IP addresses. The approach that we would take would be very simplistic. So in order to form our approach, our regex components, we will say that the digit can go from 1 character to maximum 3 characters, and we will base that to write the first regex component. So let us first form the regex to match one character, which is a digit, and the range of the digit would be from 0 to 9. So we will use the square brackets for this purpose, and we will mention the character digit range 0 to 9. So it matches all the digits. Now, in order to indicate that as a group, this character is only matched one time to three times. So it occurs only once or maximum thrice. We will use the curly brackets and we will mention the range 1, 3. So you can see that the individual components of the IP addresses are matched. Next, we will look for the literal dot, and in order to look for the literal dot, we will do \escape followed by the dot. So now you see that it's matching all the digits that has a dot ending. Now, if we analyze the IP addresses again, we can see that the component which is composed of the digits and the dot is repeated 3 times, and finally it is followed by a digit component which does not end in a dot. So let's first indicate in our regex that this component, this group, should be repeated 3 times. So in order to do that, this regex component should be put within rounded brackets. And once that is done, we will use the curly brackets to indicate the number of occurrence, number of repetitions. So 3. So now we see that it's being matched correctly. And the next step is to write the regex component to match the ending digit part. So let's do that. So the ending component is actually a digit range. So it's 0 to 9. And then it can occur 1 to a maximum of 3 times. So the final part of the IP address is matched as well. So we have a working regular expression which matches IP addresses. Welcome to this new session. In this session, we will look at writing regular expressions to match Bitcoin addresses. If we analyze the pattern in which Bitcoin addresses occur, we can see that there are capital letters, smaller case letters and numbers, and this stretch is altogether 34 characters long, and we can also notice that all these addresses are starting with the digit 1. So let us write the regex. Let us start with matching all the ones. Next, to indicate that we want to search for all uppercase letters, lowercase letters and numbers, we will use the square brackets. And we will mention the lowercase letter range A to Z and the uppercase letter range A to Z, as well as the digit range 0 to 9. Now, because the entire address stretch is 34 characters in length, and we have already mentioned 1 as 1 character, and we will only indicate that this particular range of characters need to be repeated 33 times. So we will use the curly brackets for that and mention the number 33 within it. So we have a regular expression that matches the Bitcoin addresses. And so this is the final regex. Welcome to this new session. In this session, we are actually given mock data which includes SHA-256 hashes as well as URL addresses. And the task that we have to undertake is to write regular expressions to match URLs. So let's see how this would be done. Now, if we analyze the URL addresses, we can see that it starts with either HTTPS or HTTP, and then it is followed by a colon and / 2 forward slashes. So that's the same pattern that occurs in all of the URLs that are provided in the mock data. So let us write a regular expression component just to match the first portion of the URL. So the first portion starts with HTTP, and the S is actually optional. So S could occur 0 time or 1 time. So we use the question mark sign for that. We could also have just use the curly brackets and then mention 0 and 1. It would equally work. But instead we will, for this particular example, we'll just use the question mark. And then what comes next is the colon and forward slashes. Now these are not meta characters, so they do not need to be escaped. So we'll just simply mention colon followed by 2 forward slashes. Now if we analyze the remaining portion of the URL, there there are smaller case letters, there are dots, the literal dot, forward slashes, question mark, equal to sign, the ampersand. So we would have to write a regular expression component that matches all of these different characters. And since we need a range of characters to be matched, we will use the square brackets, and we will start with mentioning the range smaller case letters A to Z, and we will also have to include the literal dot. Now dot does not need to be escaped within square brackets, so we can just mention dot, and then the forward slash, the question mark, the equal to sign, and the ampersand all needs to be matched, all of these. And because we need to match these characters at least one time or more, we will use the plus sign to indicate that. And if we quickly run through the mock data, we can see that all the URLs have been matched. So this is our final regular expression. Welcome to this new session. In this session, we are actually given textual data which is in JSON format. So there is a key which is associated with a value and a key which is associated with a value. And the task given to us is to extract out the user agent information from this data. And we can see that the user agent information occurs after the user agent key. So user agent double quotes colon double quotes, it occurs after that. So in the first line, it would be this one here until here, and then it ends where the double quotes comma double quotes country starts. So everything that is between these two, user agent and country, is the actual user agent value, and this is what we have to extract. So let us write a regular expression to just match the user agent key portion. So okay, let's do that. And because single quotes and double quotes need to be escaped, and it's a best practice to escape them, we will use backslash double quotes, then mention user agent, backslash double quote and colon, and again backslash and double quote. So now we can match the user agent key and the double quote colon double quote in all the lines. As a next step, let's just use a dot star to match the remaining part of the line as well. So let's do that, dot star, and it matches the remaining part of the lines. And next we have to modify this to indicate that we need to end at the country key. So we will look for double quotes comma double quotes country, and we will indicate that in the regex next. And so in order to look for double quotes, let's escape it with the backslash, then double quotes. Comma is not a meta character, so just simply mention that, and again backslash double quotes so that it's escaped, and then mention country. And so now in every line we have a match of text that starts with the double quotes user agent double quotes and ends at the double quotes comma double quotes country. Now in order for us to just extract out the user agent information, we know that it's what is being matched by the dot star. And so to get that information as a group, what we will do is we will just use the round brackets around the dot star. So we can see that the section that is matched by the dot star appears in a different color. And if we examine the grouping information further in the match section, we can see that all the groups, the group 1, it mentions the user agent value information. So this is what we really wanted. Welcome everyone to this new session. In this session, we are provided textual information that exists in XML format. And the task that have been provided to us is to look for postal code information. And if we analyze the textual information, we can see that the postal code, it occurs between the postal code tags here. So less than sign postal code, a greater than sign, and then the ending tag is less than sign forward slash postal code, and then the greater than sign. So what we would have to match is this value here and this value here, and so anything that occurs between the postal code tags and even this value here. So yeah, so basically our regex should look for the opening postal code tag and the ending postal code tag. So let's first write a regex component to look for the opening postal code tags. So because less than sign is not really a meta character, we can simply use it as it is, and then postal code followed by the greater than sign. So it matches all the opening postal code tags now. And next, if we analyze the actual postal code values, these are numerical data, and there could be a hyphen in between, and there could be even capital letters and a space. So we would have to write a regular expression component to include all those possibilities. So let's use a character class with the square brackets, and let's mention the digit range 0 to 9. And since it could be capital case letters as well, so the capital case range A to Z, and it could be a hyphen, it could also be a space. So let's use all those, and let's say that this character class is repeated, should occur at least one time, or a maximum of 15 characters. So let's just go with that range. So we will use a curly brackets, and we will indicate 1, 15. So we can see that the postal code values are already being matched. And let us also add a regex component to match the ending portion of the postal code. So let's say less than sign and /. Now because these are not meta characters, they do not need to be escaped, and followed by postal code and the greater than sign. So we have a full match now. And now since we only need to extract out the postal code values, we have to put whatever regex component that match the postal code values within a rounded brackets, so that it can be extracted out as a group. So we can see that once we do that, once we put it within the rounded brackets, the color changes to something else than the other matches. So, and if we examine the grouping information here, we can see that all the postal code information is being extracted out as a group. And hence we have the final regular expression that we can use to extract out postal code values from XML files. Congratulations everyone on completing this course. I would encourage you all to try and attempt formulating your own regular expressions for any pattern that you want to match. And if you face any challenges or have any question while attempting, please feel free to post it into the Q&A section. And help would be on the way. Please rate this course and help provide your valuable feedback to improve this course further. Here's wishing you well and signing off. Thank you. Bye-bye.